Good afternoon, everyone. I am Simona Neri. I'm a GuestXR project coordinator together with Mel Slater, that is the technical project coordinator. And I'm really glad today to be here to present the first webinar of this series of Unlocking the Potential of XR Shaping a Pro-Social Metaverse. This webinar is hosted by Frontiers in Virtual Reality Journal and in collaboration with, of course, GuestXR project. I would like to welcome all of you and thanks for your participation. This series of webinars explores how XR and AI neuroscience, social psychologies converge to shape inclusive, accessible, and socially impactful virtual and augmented reality environments. Today, we are having a webinar on AI-enhanced XR experience for social goods. And the speaker is here with us. I'm really glad to have you, Doron Friedman, professor and head of the Advanced Reality Lab and Richmond University. Doron is an associate professor at the Sami Ofer School of Communication and heads of Advanced Reality Labs. His academic journey began with a PhD on computer science from Tel Aviv University, focusing on AI-based cinematography in virtual environments, followed by a postdoctoral fellowship at University College London, where he explored controlling virtual reality using brain-computer interfaces. A seasoned entrepreneur, Professor Friedman has significantly contributed to the field of intelligent system and the internet, with his work resulting in several patent and commercial products. Since 2008, his lab have engaged in national and international projects related to telepresence, virtual reality, and advanced human-computer interfaces, with current focus on LLM-based virtual humans. His multidisciplinary research spanning areas such as artificial intelligence and human-computer interaction has been published in prestigious journals and conferences and frequently featured in major media outlets worldwide. So thank again to all of you for attending the meeting. After the session, we will have a question and answer slot. You can either raise your hands or write your question in the chat. We will close our webinar at 4. And this is just the first webinar of this session, but we will have a next one that will be about brain-computer interface in virtual environments, and it will be held the 30th of May by Michele Romani from GTech. And that's all. So I'm super glad to give you the floor, Doron, for your presentation. And thanks again to all the attendees.
Okay, thanks a lot, Simona. And hi, this is the strange part where I start talking to myself. I'm not even sure if you can interrupt me in the middle with comments or questions. That would be great, but I'm not sure if I can see the chat or hear your voice. Or so in the worst case, if there are comments, we'll be happy to discuss them after the talk.
Doron, we will take care of the chat in the meanwhile, no worries.
Okay, if there's something in the middle, I'm happy to do it. But anyway, to make it interactive. Anyway, so I hope we'll have time to discuss two projects. The main one I will talk about is, of course, GuestXR, but I will also mention another project with similar technologies and slightly different goal. The first one, as we said, GuestXR is a European consortium with quite a lot of topics. But one of the main, and partners doing amazing stuff, but one of the main topics is the AI agent for pro-social behavior. So let's try to see what this is about. So one place we can start is thinking about contemporary social media, which we know started as an innocent business or a way to get people to communicate on campuses and then worldwide. And then we, during the years, it turned out that it has a lot of dramatic effects, some positive, by the way, but also some unintended negative effects. And in fact, at least today, social media is not just a passive, website where you can share and click. I think most people would agree the right way to think about it is as an intelligent system that tries to understand the users and using all kinds of algorithms. Some of them AI, some of them maybe some other methods. And many of them we don't know because we don't know what's running under the hood in these corporates, but we can think about it as an intelligent learning system where the objective function is to get the user addicted or super engaged with the social media, which again, is relatively, maybe considered relatively innocent, but might have all kinds of side effects. So in this case, the input is the user activity, things like posts, shares, likes, and the action of the algorithm is what to display to you so that you will be engaged and visit the website as much as possible. And in fact, this reminds us of the reinforcement learning framework, where you have an agent, an intelligent agent that learns by trial and error in an environment. The agent has an objective, tries to satisfy it using all kinds of actions, and learns by trial and error how to achieve the goals. And this is a very hot topic these days when people are concerned about AI safety. There's these two examples that you can see on the cartoon on the right. One is on the right, it's the famous paperclip argument, where the idea is, okay, let's say that we have an agent that has to manufacture paperclips. Okay, it's a very innocent objective, but the agent is so good and has such dedication that gradually it learns that it keeps manufacturing paperclips until at some point it realizes that it starts abusing the world and the environment and people and turns everything into paperclips. And because it doesn't understand the human values, doesn't care about humans, all it knows is that its goal in life is to make paperclips. Another way to think about this problem, some refer to it as the alignment problem, is an AI babysitter, which is in charge of, again, this is of course an AI cartoon interpretation, but the babysitter problem is as follows. You have a robot babysitter, and it's told to keep the baby safe and happy under all circumstances, which sounds legitimate and innocent. But then the robot decides that the baby is hungry, or that the toddler is hungry, so it decides to cook the home pet cat or parrot or whatever and serve it as dinner to the baby. So we see that this framework, if unleashed, can be very, very powerful, but also we need to make sure that it's aligned with our goals. And that is very much in the background of the GuestXR project. Now, the GuestXR project is not about social media and AI, but about future social media, where we assume that at some point, sooner or later, people will be using XR devices instead of desktops or laptops, and maybe even instead of smartphones. Again, we don't know if this kind of metaverse vision will happen next year or in 5 years or in 20 years, but we think we assume that there's a probability that this will happen. And so we want to make sure that when we build and design the metaverse, we will avoid the kind of problems that we have in contemporary social media. And the GuestXR suggests to develop this AI agent that fosters pro-social behavior. And on the right is an illustration. We think about it as the guest. We don't want to think about it as a moderator or a manager. Assume you have an event in the physical world or in a virtual world, and it's a very boring or a problematic event. Maybe everybody's busy with their phones and stuff like that. And suddenly a new guest appears in the event and takes some actions to make sure that everybody's happy and changes the atmosphere of the meeting. So that is more or less the inspiration behind this aspect of the GuestXR project. And so now let's talk about reinforcement learning, which is the main, not only, but the main AI framework that we are working on. And so the framework, I'll give a quick intro. I guess for the listeners who are not familiar at all with RL, it might be difficult to follow, but let's try to keep it in a level that everyone can join the discussion. So it's a brand of AI, which is, unlike supervised learning or self-supervised learning, which people may be familiar with, this is an agent that interacts with the environment. And so you can see the agent. I hope you see my cursor. The agent interacts with the environment, tries all kinds of actions. The environment provides signals to the agent. The state or the next state, the information about the environment, and a reward signal. And the agent learns to maximize the expected reward over time. So it's a very interesting framework, very powerful, very elegant mathematics, plausible neuroscientific and psychological mechanisms, maybe in humans and animals. So it's a very active area of research. And we can try to explain it again in a simple way. You can think about it of the most simple version of reinforcement learning. Think about yourself. It's like you have to fill in this table, okay? And on the rows, you have different states. And on the columns, you have actions. So for example, when you're hungry, your action is to, either cook dinner or go to buy some dinner or take out, whatever, okay? And if you're, I don't know, tired, you either go to sleep or maybe you fight, you get coffee, okay? So this is a table, but so it's, think about it like the agent is learning this table from trial and error, from experiences in the world, trying all kinds of things. Q functions, this Q function or these values in the table is the value of taking a specific action in a specific state. Now, the trick here, or the interesting point about learning this table, is that eventually you want to learn it you also want to learn sequences of actions. So it's not just about a local decision of what to do now given the context, but it's also taking into account longer term effects. So for example, let's say that you are hungry, but you can choose to eat either ice cream or a cheesecake or some healthy food. So both of them will make you less hungry, but and maybe even on the short-term immediate reward, the ice cream will be better, but in the long term, the broccoli will make you healthier, for example. And that's the that's one way to look at this RL framework. And this can be achieved with all kinds of formulas. For example, what we see here is quite simple, and it says you learn it iteratively. I mean, that's one way to learn these value functions, so-called value functions or Q functions. So you can see that while you're interacting in the world, you have a certain, the table has a certain situation and values that have been decided so far. And then you take an action. In state S, you take an action A, you get an immediate reward, which is R given state S and action A. So your new reward for Q is the immediate reward that you got. And also you take into account that the action transferred you to another state, S tag. And so it's the immediate reward plus the future reward starting from S tag and going onwards, okay? In the best way, according to the best policy or the optimum policy. And this is where it gets into this long-term planning and expected reward. And then there's this discount factor, gamma, which controls if you want to satisfy immediate reward or long-term rewards. So all these things can be captured in the basic reinforcement learning paradigm. Here's a quick example. Let's say that this robot has to learn to reach this reward in the top right corner. After 5 iterations of a simple learning RL algorithm, you see that the reward of reaching the goal is 1. The reward of reaching this fire here is -1, because then the robot is burned or dead. And then you can see that gradually the robot learns to assign these states with all kinds of rewards that get higher as you get nearer the goal. And you see this is like a dead end, so it's a relatively low Q value, etc. Okay, so hopefully this is clear. Then there's deep reinforcement learning, which is much more adapted to richer environments or even real world scenarios where you replace this table. Okay, this table was easy to explain, but of course in many real world scenarios, this table is too huge, and also you want to generalize the things that you learn. So we replace this table by a large neural network, which predicts, given a state or observations about the state, maybe it's a partial observation. So given information about the state in the world, you want to decide which action to take. And then in the last 10 years, there was tremendous success, mainly by this company DeepMind, but not only, in reaching superhuman performance in playing Atari games, beating the world champion in Go, etc. Now, how do we apply this to the metaverse? How do we make the metaverse a better place? Okay, so reinforcement learning, to make it useful and learning non-trivial policies, it has to have a lot of data, or in fact, the best thing is to have a simulation, an environment that the agent can practice in. And then you can have, thousands of steps, millions of steps, sometimes many, many millions of steps, and you learn non-trivial policies in very rich environments, okay? And therefore, the project, the GuestXR project, we are first of all developing a multi-agent simulation of all kinds of social scenarios. This is done by our partners from the University of Warsaw. And then in Reichman University, in my group, we train a meta agent with the simulation, which I'll say a few words about it. And then we transfer what the agent learns to a real world scenario. In our case, the real world scenario is a multi-user XR environment, but notice that it's much, much richer than the simulation. It has real humans with verbal and non-verbal behavior, etc. So these are the steps that we take. And as a first example, let's talk about the tragedy of the commons, which is a very famous simplified use case, which was studied a lot. Even there's a Nobel Prize awarded to this person who studied this problem. The idea is, but it's a model for many examples of real-world social conflicts, if you will. Assume you have a bunch of farmers living around a common field. They have their own sheep. Now, if you don't send your sheep to the common field, your sheep will starve and will be hungry, and it's not a good policy. If, on the other hand, all the farmers send their sheep to the common field, there is a danger that the common field will be, the grass will die from overuse, and then everybody's sheep are hungry, which is also a very bad scenario. So people need to learn, the farmers need to learn to collaborate without a protocol, without a legal system, like a bottom-up emergent collaboration policy, so that they use the common resources in a smart way. This is, of course, a model that can be, you can think about it today in the case of the climate change, global warming, etc. So how do we share resources? How do we learn to collaborate to share resources? So if you consider this problem, in fact, it's been studied again by DeepMind quite a few years ago in 2017, 2018. They had a few papers where you model this problem with this environment. In this environment, it's a simulation called Harvest. In this case, it's not sheep, it's agents eating apples. Okay, maybe the red agents are sheep, I don't know, who cares? And you can see that they, well, it's not sheep, I'll tell you why. Okay, they go around the field, they eat these apples, these agents, and they can also shoot each other. You see these light blue flashes, this is when they shoot each other. Okay, and the goal is to study emergent behavior in this simulation. These metrics, mostly these metrics on the right, which is efficiency, it's basically how many apples they eat in total. Equality, do we get equality in the number of apples they eat. Sustainability is whether we have enough apples over time. In this example that you see running on the left, in the beginning, they had a lot of apples. This is an example of the tragedy. They ate too many apples. So the field was the orchard of apples or whatever it is was depleted completely. So there's no sustainability. And because they added also violence to this simulation, what happens is that when one agent chooses to shoot another one, that agent is disabled for something like 25 steps or some part of the time. So you lose one step because instead of eating an apple, you shoot. But you are more, your chances of eating apples are better because some of the other agents are idle. Okay, so you can measure the overall piece, which is the overall amount of shooting. So if you saw this first movie, you saw a bad example. You saw an example where they abused the common resources. But Perolat et al. In this paper show, this is our reconstruction of their paper, but they have very similar results. You can see an emergent behavior. And the emergent behavior, they learn to keep some apples. There is a regrowth factor so that the apples keep growing. So if you don't eat them too fast, they keep growing and you have enough apples forever. Okay, and then this is what you see. But in this paper, you can see these very nice learning curves. And okay, on the left, you have the efficiency. You can see in all these three, you can see this tragedy of the commons. Okay, you have this phase where the efficiency goes down, they don't eat apples, there's no equality, there's no sustainability, but you can see that the agents learn to collaborate. They learn not to over-abuse the apples. Unfortunately, you see in this plot, which is the peace metric, that they learn to do this by shooting each other. And this is why there's enough apples for everyone, but we consider this a problematic solution. And so our framework, well, I see that, okay. Our framework is to try to solve this problem as an example again of people behavior in the real world and also in multi-user worlds. So Asaf Kaftori, this is part of his master's thesis. He says, I want to solve this problem with reinforcement learning. However, there's an interesting problem, which is that, or an interesting challenge in RL, which is that in real-world problems, such as our examples, it's very difficult, also almost impossible, to find out the correct, the optimal reward function. Okay, deciding what kind of rewards to use is kind of an art. There's no guaranteed way to find a good reward function. And this is especially the case in large real-world case studies, but also in social simulations where we don't really have a full understanding of what drives people. So Asaf said, we have this really hot topic called RLHF, reinforcement learning with human feedback, and let's see how it can be adapted to our problem or our challenge. And the difference between a typical standard RL, as I explained it earlier, and RLHF is that instead of the environment providing the reward, there is another neural network. So the agent has a neural network or RL algorithm, but there's another neural network that tries to predict the reward. Okay, and the original paper said, well, we want to, in these kinds of problems, when we don't know the reward function, we can let humans decide what is better. So we say, okay, maybe humans cannot provide a reward function, but given two examples, they can say which one is better. One of their examples of Cristiano and al. In this 2017 paper was, I think, teaching robots how to perform somersaults. Okay, so it's very hard to come up with a reward function of how exactly to teach the robot to move its joints so that it makes a somersault. But given two attempts, humans can say this is a better attempt. Okay, so this is RLHF, and this is also has become very, very famous when this provided the leap between GPT-3 and ChatGPT. So GPT-3 was a pure language model, and ChatGPT and onwards are a combination of next word prediction language model and RLHF. Now, what Asaf is saying is, well, you know, I want to use this framework, but instead of having a human decide what is better, I can use these social metrics. So again, I don't know the reward function, but given two types of behaviors, I know what is desired. I know that we want to achieve, for example, equality or sustainability or whatever. So instead of human feedback, this is also done by others. It's called, sometimes you can call it reward learning, reward prediction, or AIF if the AI replaces the human in providing feedback. And this is how it works. This is RLHF in general. We won't get into the too many technical details, but the point is that in any given state, the learning is achieved as follows. There are two trajectories, and the reward predictor, and the information is, you know, you have an oracle. The oracle could be a human, could be a social metric, could be an AI, that given two trajectories, two examples of things unfolding in the world, can say this is better than this one, and one is better than the other. And this is used by the reward predictor. And the challenge that Asaf is facing now is to extend this framework to the multi-agent setup, okay? Because this was only demonstrated so far on single agents, like these robots performing somersaults or GPT or whatever. So that's one of the challenges that Asaf is facing. And there are two ways to approach this. One is personalized reward modeling, basically allowing a reward predictor for each agent. And another, which is more interesting, is collective reward modeling. So there is one oracle or meta agent or a neural network that learns. So think about it, it's like society. Everyone acts in their own interest, more or less, but there is also some regulator that encourages the overall social behavior. So this is collective reward modeling. And this is another way to think about it. If the reward is personal per agent or in general for everyone. Okay. So we have some results from Asaf's work. Let's go over them quickly. These are some plots. So first, this is just trying to reconstruct the original problem to increase efficiency or the number of apples that the agents consume. On the bottom, so these are the four general metrics, and here you can see this is a plot of showing the original reward and the reward predictor. So you see that they are highly correlated, which is good. The correlation goes up to 1. And this is a loss function. It's not stable, but it's not uncommon in deep reinforcement learning. This is not very interesting. What is interesting here is that you see that this reconstructs the Perolat et al. Tragedy. Okay, so this is this tragedy of the commons, and the agents, even with a reward predictor, do learn to get out of this problem, achieving efficiency, sustainability, etc. And like the original problem, this comes at the expense of peace. They learn to shoot each other. Okay, now what Asaf can do is, this is where the important difference here is here. The difference is the goal now for the reward predictor is to satisfy efficiency times peace. So like both of the goals, and you see that efficiency goes up, sustainability is okay, it's not high enough, equality is very high, and importantly, peace is very high. Okay, yeah, and this is again the reward predictor is okay, it's converging to 1, the loss function is okay, etc. Let's quickly see how this looks like for efficiency times peace. So you will see that they learn to leave some apples, and they are relatively non-violent. You see that there's very little these blue flashes that are violence, and you see that they learn to keep the apples so that even in the end of the episode, they still have a lot of apples. So this is a success. Yeah. Now, quickly, I will show you ongoing work that is not yet published, but I do want to explain how this is related to the metaverse, which is more important. So this is ongoing work with the University of Warsaw, University of Barcelona. In this case, we do not care about, so the goal is you have a multi-user discussion. Instead of Zoom, it happens in multi-user VR or AR. And in this case, we are not interested in the content of the discussion, although of course we can add LLMs, etc. But we are interested in turn-taking and non-verbal behavior. So in Warsaw, they built this kind of simulation where you see who, people speaking and who are they looking at. And this is how it looks like in VR. These are some people having a discussion. Einstein is the guest in this case. This is, of course, Professor Mel Slater, for those who know Mel. They are having a discussion, and Einstein occasionally will take some actions in order to moderate the environment, to regulate their behavior, maybe encourage one of the students who is shy to speak more by looking at them, by maybe addressing them, etc. And this is kind of work in progress.
Okay, now he's looking at me.
Yeah, Einstein is looking at Mel in order to encourage Mel to speak or whatever. You can see here the learning curve with comparing two algorithms. This is in the simulation, comparing the reward predictor that Asaf developed with a standard RL algorithm. And both of them work, but the reward predictor is even better. And this is just for fun. I can show you how this will look in XR. This is a meeting that we had in my office. So you see all these avatars floating in my office. This is in the Quest Pro, Quest 2, and the Apple Vision Pro. So that this is just to show that these kind of things could take place in AR. Not necessarily.
So I'm a white guy. I'm a white.
These are all kinds of content that we're developing in part of the guest. And hopefully in a few months, or we will be happy to provide more details. Okay, so this concludes the main topic. Now I will take some, I guess I'll take some 12 minutes to tell you about another project, which is the interim name is Finding the Tools. And it's using similar techniques, combination of AI and XR. But in this case, the goal is different. The goal is to encourage basically mental resilience. Let's see what this means. So the project started, of course, with COVID-19, not with COVID-9. Sorry about this spelling error. Already a few years ago, we noticed that there is a lot of distress worldwide and locally. And the solution, which my colleague, Professor Anat Klomek-Bronstein, who's a researcher in clinical psychology, said, well, there is this set of tools called resilience. And we want to teach people, encourage and teach resilience as if it was a muscle. We'll say a few more words about this. And so it's a very kind of straightforward solution. We build a VR simulation with virtual patients for training people to increase their own resilience, or to train teachers, people like psychologists, social workers, to help others. I'll try to say a few more words about this later. But interestingly, this project has two interesting aspects. I think one is the application, which is encouraging resilience, practicing resilience skills. And the other is the underlying technology, which is based on AI for automated XR generation. And I hope we will say a few words about both of these things. Okay, so a really terrible twist of fate, we had October 7th in 2023, which was still is a huge trauma for almost basically everyone in Israel. And by the way, of course, also in Gaza and in Lebanon and in other parts of the Middle East, this is not about who is right in this war. I hope we agree that the most important thing is to prevent such terrible wars, but the amount of suffering and distress is really unbearable. So here, again, some of this will be in Hebrew, and I'll tell you about the story from the Israeli side. But of course, this applies to other sides of other conflicts and many other tragedies. This is a story from December last year saying that 83% of the kids in Israel suffer from emotional distress, 62% of them suffer from anxiety, but only 14% are seeking mental help. And of course, there is a huge shortage of mental therapists. So this is the challenge we were facing as a country. And there was a private donation, which is kind of an effort to work with the community of clinical and psychologists and to train a lot of people, which is a very interesting issue. Like, how fast can you train someone, you know, instead of a clinical psychologist who's gone through many years of training? Who do you want to train? Do you want, so maybe it's not for everyone, but maybe you can take teachers, social workers, and train them. And this is better than, you know, it's not as good as a professional psychiatrist or trained psychologist, but we still need these training. Even more so, wait, I think I might have the wrong slides. Let's see if we have the nice slides. Yeah, okay. Anyway, we'll give it a try. Anyway, so there's another twist here, which is by helping. So there's two things here. Formally, we're starting by training these professionals or semi-professionals. They train with a virtual patient and they teach them these resilience skills. But then there's another question, which is, okay, I know what we're doing here. So there's a library of scenarios where you train specific skills, talking to a virtual patient in VR. And here is the point that I wanted to get to. So there is this, you know, a popular belief, which I always suspected that it's not true, which is that, you know, this, you know, I'm sure you all know these phrases in multiple languages, which is something like, what doesn't kill you makes you stronger. Now, we don't know if it's true, but we do know that, and again, this is not my expertise, this is stuff that I'm learning from our clinical partners. It's quite clear that some people are less affected by trauma, and they call it resilience. They look at it today as a set of skills that each person have, but they say, look, we can learn, we can teach these skills, and we can practice them. It's like working in the gym on specific muscles. So this is not PTSD treatment, this is PTSD prevention, okay? And in a few cases, there's even post-traumatic growth. I do want to give you an example, which is actually my daughter. I was really inspired by my daughter, who was 22 years old. And again, I'm telling you my own personal story, but of course, you know, there's no agenda here. It's like, for many people like myself, this was a complete trauma. October 7th, with the terrible things that happened, burning people alive, rape, etc. And it's all people we know. And I talked to my daughter. I had this, you know, conversation where I wanted to ask how she's doing. And she says, look, I'm okay. I don't have any close friend. I could be in this party in the Nova, but I don't have any close friend who was killed. I know some more people, but, and so instead of complaining, I will go to help. So she went to volunteer with dislocated people. Still, we have a few 100,000 people dislocated, etc. And the idea is that she found by herself one thing that is very important in this program, which is that by helping others, you also learn to help yourself. Again, it's all these kind of popular cliches, but apparently they have scientific evidence. So this resilience training is one, officially it's for professionals or semi-professionals to help others, but we also intend in the future to maybe make it for everyone. So this is what it looks like. And then I want to say a few words on the technology, which is very relevant also to the GuestXR project and to many other projects in the Metaverse. So I'll say a few words about that. The first thing is dialogue. So there's three approaches on one side of this, and we've done all of them, and we've learned a lot from these projects. I won't show you these videos, but I'll say a few words. You can watch them on our website, on the lab website, YouTube channel. One approach is so-called Wizard of Oz. You don't use AI, you have these menus, and an operator basically chooses the correct response. Surprisingly, this is sometimes preferred in real-world scenarios. Anyway, there's an operator, and then you have perfect timing, perfect control, and so the virtual patient is kind of controlled by a Wizard of Oz approach. On the other hand, on the other extreme, we have these LLMs, or things like GPT. GPT-4 now is amazing. So you say, okay, why not have dialogue with GPT? And we're doing that, and we've published papers, and we're working on this in the lab. But for this applied project, we found out that structured dialogue is preferred. GPT, although I'm sure there's a lot of companies and people working on it, we don't always rely on it to, there's these hallucinations, there's unpredictability. So we don't want to unleash it as is, as an open-ended dialogue. And especially for training, where we know exactly what we want to achieve in a session. We want to control where the conversation goes. So instead of using an LLM as an open-ended dialogue system, we use it with some restraint. Usually it's asymmetric. You use, the best AI that you can for understanding speech and text, but then the generation is done using more simple algorithms in a controlled fashion. And in practice, and what we're doing in this project is even more simple, because we really intend it, like today, as we speak, there's a pilot in one of the largest mental hospitals. People are training to use it. Okay, so this is the functionality of the product. You choose, there's an opening, you choose the episodes, you choose the opening, cognitive skills. Again, I'm sorry, it's in Hebrew. We will be happy to make it available. We are already working with colleagues in Ukraine, and I'm sure we'll be happy to localize it to other nations. I mean, it's not only war. The good thing about these resilience skills, with our crazy world, it could be good for many people. So there's things like emotional skills, cognitive skills, behavioral skills, bodily skills, and interpersonal skills. So you choose your episode, you can do them one by one. So it's a bunch of models. It's a lot of VR content. This is what, for example, and each content comes in two fashions. First, there's training. You watch a scene as an observer. You see how to talk to someone in distress and practice the specific skills. And then you practice it with this patient. Okay. And again, I'm sorry it's in Hebrew, but, and actually this image is confusing because this is usually when you're in the training, the more interesting interactive part, you see it in the frontal view. So this is the therapist is on the right, the patient is on the left, and you will be talking to her and seeing her from your angle. And then you have, and this is done deliberately again, in your turn in the dialogue, you're given three options. We don't want a free dialogue because we want you to train on specific skills, but you read them out loud. You don't click a button. So you have this, and it's done in VR. So it's kind of a practice with high ecological validity. And yeah, you could be correct. You get feedback in the body language and correct, incorrect. And you get status of how many models you've practiced, etc. Okay, now last 2 minutes, let's talk about the technology behind it, because this is a lot of content. And what we're doing is we're using AI to generate this VR content automatically. So you can think about it, there's two approaches. The straightforward approach is to say, well, we develop an end-to-end AI system which converts text into movies. We don't have it yet, or into VR, right? We don't have it yet. But we know that AI is making, okay. Let me take 1 or 2 more minutes, but we will conclude. So we know that AI has made amazing and really fast progress in generating, for example, text to images. I'm sure many of you, maybe all of you have seen, Sora very recently announced on converting text to movies. So we say, okay, it's just a matter of time before we have this end-to-end neural network where you can type in a script and get a VR scenario. And we're not there yet. And this guy, Dan Pollack, who is a student in the lab, actually the CTO of the lab, has been working with us for quite some time. And he knows AI, but he really likes XR, and he thinks that even with the advance of end-to-end systems, there is, he thinks, at least a few years where we want to have more control. And rather than an end-to-end system, we have a standard pipeline for XR production, which makes it easier and faster, yet you can also have control as a Unity programmer or designer to play with a tool. So let me go over this quickly. So the punchline is that you take a script in English, things like Alice was very angry at Bob. So this can be passed. First of all, it's automatically generated voice of what Alice and Bob are saying, but also based on this sentence, the AI assumes that the animation played from a large bank of animations is of an angry Bob. Okay, so this is an example. And another way to think about it is the system allows you automatic conversion from text to a JSON structure, which captures basically the script, but also decides which animations to play for face, for gestures, for multiple characters, and automatically converts it into a Unity project that actually works. Now, the interesting advantages of this program, of this framework, is that you can play with multiple, on these layers, you can modify the text here, and then everything is changed, but you can also go backwards. And this is the stuff that now Dan is supposed to complete with the other members of the team, mostly Niv and Maya, Niv Rosnovsky, Maya Shekel. And basically, imagine that you did this, but then you're unhappy. In Unity, you make some changes. So it's kind of like an automatic version control. We want this also to go in the backwards and keep all of them consistent. And you can also see visually, this is the script that we had in this simple dialogue. Could be any tree-like narrative, but in our case, it's a dialogue, and there's 3 types of answers, and then depends on the user action. You get these responses, and then the script continues linearly. So this is an example of the Inceptor. Skip the video, and because it's in Hebrew, and because we're still working on improving the animation. But this is to conclude. So we saw 2 kinds of projects. One that we're working with a team of researchers in Europe, mostly with Andre and his team, Mel and his team, but also some others, and some local experts. And also quite a few students contributed to, these are only the students that contributed to the projects I showed today. And the next thing I think we want to, so that's it for me. I think we do want to remind you that the next talk in the series will be by Michelle or Michele, depends if they're from, well, I guess it would be Michele if they're from Trento, talking about BCI. Thank you very much.
Thanks a lot, Doron, also for taking over the presentation of our next webinar. So it's time to open the question and answer session. I see we have 2 questions. The first one is, hi Doron, thank you for the presentation. It was very interesting. I would like to ask, what are the key challenges and opportunities in applying LLMs like ChatGPT to the development and enhancement of the metaverse?
Right. So we've done quite a lot of work and published some papers on this. And today I didn't talk about these projects, but I think we will have them in the guest as well. You are welcome to check a paper by the first author is Shoa, S-H-O-A. It's called Sushi with Einstein. But it sounds really simple, like, okay, you know, we have LLMs, Python, we send some instructions to Unity. So in this paper, we explain there's quite a lot of challenges with the, you know, integration challenges, voice, understanding, speech generation. Actually, speech generation in English works perfect, in other languages, in some languages, it's still not good enough. So there's all kinds of problems and also all kinds of opportunities. I also have a paper that is not yet published, but it will be published soon, and I think it's very interesting. We had a project. It's not, I think it's, I will try to explain the twist because there's many things you can do. It's not just about talking to an AI with, like an automated therapist. We have a study, again, with Mel's group in Barcelona, where you are doing a self-conversation. So we have a lookalike avatar. You are helping yourself. You are having a discussion with yourself. It's a very interesting twist. You should check Mel's papers. But in our case, in our joint study, if you try to give advice to yourself, but if you're stuck, there's another guy in the room, which is the LLM, and the LLM can listen to the conversation and give you some advice. So if the LLM is not good enough to be a licensed psychiatrist, it can still be useful to encourage you. Okay, so there's a lot of opportunities, but also, performance, delay, etc. There's some more information in the paper.
Okay, thanks. I think it's really comprehensive also because you are providing good references to be checked afterwards. So we have other questions from Padmaja. Hello, Doron, amazing work. Thanks for presenting. Are you open for collaboration? I'm building a solution for survivors of gender based on violence to learn interpersonal skills for self-advocacy and other relationships. This is an invitation.
No, absolutely. We're open to collaboration. We really learned, we started in COVID-19 and now we have this terrible war. But then when you realize that there's so many problems in the world, some of it is human caused, some of it is, just disease and accidents, there's so much suffering. And we do believe, and Anat is a strong believer, she's a leading psychologist working in practice. She believes in this solution. And hopefully out of all these troubles, we will have this kind of basic product that we can help share with others. So do contact me on email, or you can find me, Doron Friedman, in Reichman University Herzliya.
Also, throughout the webpage of GuestXR, you can reach out, at least myself, and then I can forward the email in the case it is needed. Another
That's
one.
wonderful. Thank you so much. I'm based in Boston, and I'll certainly reach out.
Yeah, exactly.
Okay.
Our framework, we hope that, you can create, it's not 100% ready yet, but unfortunately, thanks to the war, we are getting there. And as I said, today we're testing it, so you can write your own narrative and just click a few buttons and you get a VR scenario. As long as it's
That's
social.
exactly how I have envisioned it, and you're already creating it. I'm really happy, and I'd love to see how I can contribute, and also how we can collaborate using your platform. So I don't have to build my own platform. I can use yours.
Yeah, I'm sure there will be enough work left, I'm sure. Okay.
Thank you.
And what else?
Thanks. We have another one that is a bit tricky. Thank you for your presentation, Lazaros Rafael Koutzelis. I hope I'm pronouncing it properly. How can we trust the output of an LLM in application where we aim for empathy and factuality, such as social care experience?
Okay, so again, this question is really, it's exactly why I mentioned that in this application, we avoid using LLM. We do use LLMs, but only to understand that what you're saying out loud matches one of the responses. But this is exactly why I mentioned that we work with structured dialogue, because we don't trust the LLMs completely. And I think we encourage everyone to be very careful. Having said that, we do believe that LLMs today are getting better and can be trained and tamed to provide sometimes a satisfactory solution. Again, I encourage you to look at two of our papers on LLMs, not on VR, in collaboration with Kfir Ba, with our NLP collaborator, where in one of them we show how you can use it for motivational interviewing, which is exactly interviewing. It's kind of a simple treatment with empathy. So we provide a data set and show some use of LLMs to score things. And then we have a very interesting, this is by the way presented in Torino next week by Ben Cohen, the student. And then there's another paper that I hope there will be a longer paper, but there's a short paper where again, the first author is Tav Yosef, last name Yosef is Y-O-S-E-F, where we show that we validated LLMs as virtual patients, which can be used as to measure and validate virtual therapists. So again, we think it's a very interesting challenge. We think it's possible, but we are in fact concerned that people are using LLMs without verifying what they get out of it. Okay, so we've written some papers about this, and I'm still working on it.
Thanks a lot. I see that there isn't any other question in the chat. I don't know if there is anyone else from the attendees that want to raise the hand.
We have one more question I can address, GPT-4o. Hey, you know,
No, recently.
No, it's fine. Everybody keeps sending me these videos. I think it's a great, I'm sure it's a great system. I still didn't have time to check it in depth, but it's definitely improving, for example, voice. So yes, if you ask me, and I think these things will converge into VR. You see it gradually going text, images, voice. There is, at some point we split. There is the generation of 2D avatars, companies like DID or Synesthesia. There's all kinds of companies making these deep fakes. And we have decided to go another way, which is to generate a whole scene in 3D with avatars. But I'm sure that if and when, you know, at some point, you know, in the pace that things are going, it could be just a few days or weeks or months, maybe a few years. I think we will see things go beyond the voice, and this will make it easier for us to move to the next challenges, which I think we will still have in XR.
Okay, perfect. So if there is any other question, I would like to thank everyone for attending this meeting. Also, of course, Doron for giving us this nice talk. In the meanwhile, I take the opportunity to reply also to the question related to the presentation. During the next week, we are going to send both the recording of the session and the slides of the presentation, so you will be able to have it. And so thank you again for your participation, and I hope to see you in our next webinar.
Thanks, Simona and Marina. Thanks for all the feedback. Looking forward to hear your comments. Open to collaborations with GuestXR and in general. Bye-bye.
Thanks a lot. Bye-bye.